Today we will be adding and subtracting radical expressions. It's kind of like combining like terms with variable expressions. And with variable expressions, the variables have to have the same exponent raised to the same power, or same variable combination. And it's the same thing with radical expressions as well. So if you look at the 175, underneath the radical sign and the 28, they're not the same, so we cannot add them at this stage. However, what we can do is we can look for perfect squares to take them out. So the ones that you want to look for are the square root of 4, the square root of 9, the square root of 16, square root of 25. These are ones that are perfect squares, and these are the most common ones that you'll see in the numbers. So for instance, if numbers end in 25, 50, 75, or double zeros, we can divide by 25. And that's what I'm going to do here. So I'm going to take out that 25 from 175, and when I do that division, I'm left with 7. And so I'll do the same thing with the 28. So I'll bring down the plus sign, square root of 28. Well, I see a 4 can go into the 28, so I'll divide it by 4 and do the same thing. And see what's left over? I get 7 left over. Now I can take the square root of 5, or square root of 25, which is 5, and I can take the square root of 4, which is 2. And notice now I have the same radicand, so I can go ahead and combine these as 1. So 5 square roots of 7 plus 2 square roots of 7 makes 7 square roots of 7, and that would be our answer. So that's what I'm looking for. I'm looking for perfect squares. So when I look at this number, I see 16 goes into it. And if you didn't see it right away, you could start with 4, but then you'd see that we could have 4 go into the 40 once more, and so that's actually 4 goes into the 20 once more. So you could take out a 16. 16 times 5 makes 80. Do the same thing here, minus, and then here we have a perfect square. You're not looking for 2 and 10, you're looking for the perfect squares, like 4 and 5. And so 4 is a perfect square, so I'll be able to combine these as 1 shortly. So I bring down the 2, take the square root of 16, which is 4, and then bring down the square root of 5, minus 2 square roots of 5. So I go ahead and do the work a little further. I get 8 square roots of 5, take away 2 square roots of 5, which leaves me with 6 square roots of 5, and that is our answer. Well, here we just have 3 terms, but again, as I'm looking at these radicands, the numbers underneath the radical signs, I'm looking for perfect squares. So I see 4 times 2 makes 8, and 4 is a perfect square. Here I see 4 goes into it, but I see a bigger number. 16 goes into 32. So you're always looking at the perfect squares and looking for the biggest one you can take out. And you bring down that 2, and then you look for the perfect square, and it's 9. 9 times by 2 makes 18. So now I go ahead and take those perfect squares. So I bring down the 5, and it's being multiplied by the square root of 4, which is 2. And then bring down that square root of 2, minus 4 square roots of 2. Plus 2 times by 3 square roots of 2. So I get 3 from taking the square root of 9. So now I can multiply. So I got 10 square roots of 2. Take away 4 square roots of 2. Plus 6 square roots of 2. Go ahead and do a little more work there. 10 minus 4 makes 6 square roots of 2. Plus 6 square roots of 2. Leaves me with a total of 12 square roots of 2. And that's in the simplified form. Over here we have the same sort of thing, but this time some variables involved, and that's okay. Just again, take out the perfect square. So again, as you're doing it, you're thinking of 4, 9, 16, 25. When the numbers end in 5 and 0, that means 25 can go into the number. So the square root of 25. And we've got a 6r left over. R is not a perfect square, so I'm going to just leave it right next to the one that's not. Over here I see 54 can have a factor of 9, so we'll take out that 9. And then I also have 6 and r left over when I divide that 54 by 9. So I take those square roots. I got 5 square roots of 6r plus 3 square roots of 6r, and that makes a total of 8 square roots of 6r. That is our answer. So again, as I'm doing it, I'm looking for those perfect squares. I see 9 goes into 63, so what's left over is the 7x minus 4 times by, and then the square root of 9, and then I've got 3x. So when I go ahead and do the work, I've got 3 square roots of 7x, because I took the square root of 9, which is 3, minus 4 times by 3 square roots of 3x. Well, I can go ahead and not combine, but multiply a little bit. So I'm left with 3 square roots of 7x minus 12 square roots of 3x. Now, just because they have an x doesn't mean I can combine them. They have to have the same coefficient as well. So that's as far as I can take the problem. I cannot combine these two in this case. Well, the next one, again, you're looking for the biggest perfect square. 4 goes into 48, but 16 does as well. So take out the biggest number. What's left over when you divide by 16 is 3p, plus 3 times by square root of 9 times, and then what's left over is 2p. And then here I have minus 2 times by the square root of 9 again, and what's left over is 3p. So I go ahead and do some work. We get 4 square roots of 3p, plus 3 times by 3 square roots of 2p. And then we have a minus 2 times by 3 square roots of 3p. So we go ahead and multiply the numbers to simplify a little further. Got 4 square roots of 3p, plus 9 square roots of 2p. And then over here we got minus 6 square roots of 3p. So I go ahead and collect any terms that I can. In this case, I can only collect the ones with the same radicand, number underneath the radical sign. Has to be the same in order to combine, and so that makes a total of negative 2 square roots of 3p. Notice that I had opposite signs, so I subtracted more negatives than positives. And then just bring down that plus 9 square roots of 2p, and that is our answer. Well, the next one asks us to find the perimeter. Give your answer as a radical expression in simplest form. And so all I'm going to do is, since I need to find the perimeter, is add up all the sides. So they're all in feet, so I'm just adding up the numbers. So I got 1 plus 1 plus 1 plus the square root of 2 plus the square root of 8. And so I go ahead and add these ones together. You get 3 plus the square root of 2 plus, now I'm going to take out the perfect square in 8, which is 4. Square roots of 2. So I go ahead and collect a little further. So I'll bring down the next step. I got 3 plus the square root of 2 plus 4 square roots of 2. Well, now I can collect these two last terms in this 3-term polynomial here, and it's these two right here that I can collect, or this radical expression, I should say. So I go ahead and count them up. I got how many square roots of 2? Well, you got 1 here, and 4 makes 5. So I got 5 square roots of 2. And then I've got that plus 3, so I'll just put the 3 on first here in this case. So 3 plus 5 square roots of 2 feet is my answer, the perimeter of this polygon. So those are types of problems you'll see on tonight's homework. Good luck.